What if humanity's greatest achievements were still ahead of us, waiting in the stars? Picture this. On one hand, we could transform Mars, a barren desert world, into a lush, Earth-like paradise. On the other, we could build a colossal megastructure around the Sun, capturing its energy on a scale that defies imagination. Both ideas sound like science fiction, but they're grounded in real science, and they represent two of the most ambitious dreams humanity has ever conceived. So which one would be cooler, terraforming Mars, giving us a second home among the stars, or constructing a Dyson Sphere, unlocking the power of an entire star? In this video, we're diving deep into these two futuristic visions, breaking down the science, the challenges, and the sheer awe-inspiring potential of each. By the end, you'll not only understand what it would take to achieve these feats, you'll also decide which one captures your imagination more. Let's explore the future of human ambition and technology together. Terraforming Mars, it's a phrase that sounds like it's straight out of a sci-fi blockbuster, but it's actually a serious scientific concept. Imagine taking a cold, barren, and lifeless planet and turning it into a vibrant, Earth-like world where humans could thrive. That's the essence of terraforming. The goal is to transform Mars's thin, carbon dioxide-heavy atmosphere into something breathable, warm its freezing surface, and create conditions where liquid water and life could exist. But how would we even begin to tackle such a colossal project? The first step would involve warming the planet. Mars is frigid, with average temperatures hovering around -80 degrees Fahrenheit. To make it habitable, we'd need to kickstart a greenhouse effect, trapping heat to raise the temperature. One idea is to release greenhouse gases like methane or carbon dioxide into the atmosphere, which could help trap solar energy and gradually warm the planet. Another wild proposal involves redirecting comets or asteroids to crash into Mars, releasing water and gases that could thicken the atmosphere. But warming Mars is only part of the challenge. The planet's lack of a magnetic field leaves it vulnerable to harmful solar radiation, which would make long-term survival difficult for humans. To solve this, scientists have suggested creating artificial magnetic fields, possibly by placing massive electromagnets in orbit around Mars. These shields could deflect radiation, making the surface safer for life. Then there's the issue of oxygen. Mars's atmosphere is less than 1% oxygen, compared to Earth's 21%. To fix this, we'd need to introduce microorganisms or plants capable of photosynthesis, slowly converting carbon dioxide into breathable oxygen over centuries. It's a slow process, but it's one that could eventually make Mars's air safe for humans. Of course, all of this raises the question, is terraforming Mars even possible with our current technology? The short answer is no, not yet. The scale of the project is staggering, requiring advancements in planetary engineering, biology, and energy production that we're only beginning to explore. But the idea isn't just about feasibility, it's about vision. Terraforming Mars represents humanity's drive to push boundaries, to take control of our environment, and to ensure our survival beyond Earth. It's a dream that challenges us to think bigger, to innovate, and to imagine a future where the stars are within our reach. So, while terraforming Mars might seem like a distant dream, it's a dream rooted in real science, and one that could redefine what it means to be a spacefaring civilization. But before we get too carried away, let's consider the other side of the coin. What if, instead of transforming a planet, we built something even more ambitious? Something that could harness the power of an entire star. That's where the concept of a Dyson Sphere comes in. Now, let's take a closer look at the challenges of terraforming Mars. While the idea of transforming a barren world into a second Earth is undeniably thrilling, the reality is far from simple. Mars is a hostile environment, and reshaping it into something habitable would require overcoming some of the most daunting obstacles humanity has ever faced. First, there's the issue of Mars's atmosphere. It's incredibly thin, about 1% the density of Earth's, and composed almost entirely of carbon dioxide. For humans, this means no breathable air and no protection from harmful radiation. Even if we could warm the planet, we'd still need to figure out how to generate enough oxygen to sustain life. Introducing photosynthetic organisms or algae might help over time, but this process would take centuries, if not millennia, and even then, maintaining a stable atmosphere would require constant monitoring and intervention. Then there's the problem of gravity. Mars has only about 38% of Earth's gravitational pull. While this might sound like fun at first, imagine bouncing around like an astronaut. It could have serious long-term effects on human health. Prolonged exposure to low gravity can lead to muscle atrophy, bone density loss, and other health complications. Creating artificial gravity or finding ways to mitigate these effects would be essential for any long-term settlement. But perhaps the most overlooked challenge is Mars's lack of a magnetic field. Earth's magnetic field protects us from the sun's radiation, but Mars lost its magnetic shield billions of years ago. Without it, the planet's surface is bombarded by cosmic rays and solar particles, making it a dangerous place for humans. Building artificial magnetic fields or underground habitats could offer some protection, but these solutions would be incredibly complex and resource-intensive. And let's not forget the ethical questions surrounding terraforming. Should we even attempt to alter another planet's environment? What if Mars harbors microbial life, even in its most primitive forms? By terraforming the planet, we could inadvertently destroy ecosystems we don't yet understand. These moral dilemmas add another layer of complexity to an already monumental task. Despite these challenges, the idea of terraforming Mars continues to captivate scientists and dreamers alike. It's a project that pushes the boundaries of what we think is possible, forcing us to confront not only technical hurdles but also philosophical questions about our place in the universe. While the road to a habitable Mars is long and fraught with difficulties, it's a journey that could redefine humanity's future. But what if, instead of reshaping a planet, we aimed even higher? What if we built something so vast, so ambitious, that it could dwarf even the grandest terraforming project? That's where the concept of a Dyson Sphere comes into play, a megastructure designed to harness the energy of an entire star. Let's explore what that would entail. If humanity set its sights on terraforming Mars, one of the first questions we'd need to answer is, how long would it actually take? The timeline for transforming a cold, barren world into a habitable paradise isn't just a matter of decades, it's a project that could span centuries or even millennia. Let's break it down. Warming Mars, the first major step, might take around 100 years. This could involve releasing greenhouse gases into the atmosphere or using giant mirrors in space to reflect sunlight onto the planet's surface. These methods could gradually raise temperatures, melting frozen carbon dioxide and water ice to kickstart a greenhouse effect. But even after Mars warms up, we'd still face the monumental task of creating a breathable atmosphere. This is where things get really slow. Generating enough oxygen for humans to breathe could take thousands of years. We'd likely rely on genetically engineered plants, algae, or microorganisms to convert carbon dioxide into oxygen through photosynthesis. While these organisms could work tirelessly, the process would be painstakingly gradual. Imagine planting forests on Mars and waiting centuries for them to grow, all while hoping they can survive the planet's harsh conditions. And then there's the question of patience. Would humanity stay committed to such a long-term project? History shows that we often struggle to maintain focus on goals that stretch beyond a single lifetime. The construction of cathedrals in medieval Europe, for example, sometimes took hundreds of years, with generations of workers dedicating their lives to a vision they'd never see completed. Terraforming Mars would require a similar level of dedication, but on an even grander scale. The timeline also raises practical concerns. Over such a long period, political, economic, and social priorities could shift dramatically. Funding for the project might dry up, or new technologies could emerge that make terraforming obsolete. There's even the possibility that by the time Mars becomes habitable, humanity might have developed other ways to thrive in space, such as advanced space habitats or faster interstellar travel. Despite these challenges, the idea of terraforming Mars remains a powerful symbol of human ambition. It's a reminder that some of our greatest achievements require not just innovation, but also patience and perseverance. The timeline might be daunting, but it also forces us to think beyond our own lifetimes, to consider the legacy we want to leave for future generations. So, while the dream of a green, thriving Mars might be centuries away, it's a dream that challenges us to think bigger and plan further ahead than ever before. But what if we didn't want to wait that long? What if we aimed for something even more ambitious, something that could provide immediate benefits on a cosmic scale? That's where the concept of a Dyson Sphere comes into play. Now, let's shift our gaze from the red sands of Mars to the blazing heart of our solar system, the Sun. What if, instead of reshaping a planet, we built something so vast and ambitious that it could dwarf even the grandest terraforming project? Enter the Dyson Sphere, a concept that pushes the boundaries of human imagination and engineering. Proposed by physicist Freeman Dyson in the 1960s, a Dyson Sphere is a megastructure designed to capture the energy output of a star. Picture this: a colossal swarm of solar panels orbiting the Sun, soaking up its immense energy and funneling it back to Earth or other human settlements. The idea is as simple as it is revolutionary: harness the power of an entire star to meet humanity's ever-growing energy needs. But what would a Dyson Sphere actually look like, contrary to the solid, shell-like structure often depicted in science fiction? A realistic Dyson Sphere would likely consist of millions or even billions of individual solar collectors, arranged in a vast swarm around the Sun. These collectors could be massive solar panels or mirrors, each one capturing a fraction of the Sun's energy and transmitting it back to where it's needed. The scale of such a project is almost incomprehensible. The Sun emits an estimated 386 septillion watts of energy every second, enough to power human civilization millions of times over. A Dyson Sphere would allow us to tap into this virtually limitless energy source, solving Earth's energy crisis and enabling us to power everything from interstellar travel to advanced megacities. But here's the catch: building a Dyson Sphere would require technology and resources far beyond anything we currently possess. For starters, we'd need to mine materials on an unprecedented scale, potentially dismantling entire planets or asteroids to gather the raw materials needed for construction. We'd also need to develop advanced robotics and automation to assemble and maintain the structure in the harsh environment of space. And then there's the question of time. Even with futuristic technology, constructing a Dyson Sphere could take centuries or even millennia. It's a project that would require the cooperation of generations, with each one contributing to a vision that might not be realized in their lifetime. But perhaps the biggest challenge is the sheer audacity of the idea. A Dyson Sphere isn't just a technological feat, it's a statement. It's a declaration that humanity is ready to step onto the cosmic stage, to claim the energy of a star and use it to fuel our dreams. It's a vision of a future where we're no longer bound by the limits of our planet, but instead empowered by the limitless potential of the universe. So, while the idea of a Dyson Sphere might seem like science fiction, It's grounded in real science, and it represents one of the most ambitious dreams humanity has ever conceived. But as we'll see, the challenges of building such a structure are just as monumental as the rewards. Let's dive deeper into what it would take to turn this vision into reality. Building a Dyson Sphere isn't just a challenge, it's a challenge on a cosmic scale. To even begin such a project, we'd need to rethink how we gather and use resources. The materials required would be staggering. Imagine dismantling entire planets or asteroids, breaking them down into raw elements like iron, silicon, and aluminum, just to build the millions of solar collectors needed. This alone would require mining operations far beyond anything humanity has ever attempted, not to mention the advanced robotics and automation needed to carry out such tasks in the vacuum of space. But gathering materials is only the first hurdle. Assembling the Dyson Sphere would be an engineering nightmare. Picture trying to construct a structure so vast that it could encircle the sun. Each solar collector would need to be precisely positioned and maintained, all while orbiting at incredible speeds. Even the slightest misalignment could cause catastrophic collisions, sending debris spiraling into space. And let's not forget the sheer distance involved. The sun's immense gravity and radiation would make construction a dangerous and delicate process. Then there's the issue of stability. A Dyson Sphere isn't a static object. It's a dynamic system that would need constant adjustment to remain functional. Solar flares, gravitational pulls from nearby planets, and even the movement of the collectors themselves could destabilize the entire structure. Engineers would need to develop advanced systems to monitor and correct these fluctuations in real time, ensuring the sphere remains intact and operational. But perhaps the most pressing challenge is energy transmission. Once we've captured the sun's energy, how do we get it back to Earth or other colonies? One idea is to use microwave or laser beams to transmit the energy across vast distances. However, this would require incredibly precise targeting and infrastructure to avoid losing energy or accidentally frying something or someone along the way. Another option is to store the energy in massive batteries or fuel cells and transport it using spacecraft, but this would add another layer of complexity and cost to an already monumental project. And let's not overlook the human factor. Building a Dyson Sphere would require unprecedented global cooperation, not just in terms of resources and technology, but also in vision and commitment. It's a project that would span generations, demanding patience, collaboration, and a shared sense of purpose. History has shown that humanity often struggles to unite behind long-term goals, especially ones as abstract and distant as a Dyson Sphere. Despite these challenges, the idea of a Dyson Sphere remains a tantalizing vision of the future. It's a project that pushes the boundaries of what we think is possible, forcing us to confront not only technical and logistical hurdles, but also philosophical questions about our place in the universe. Could we, as a species, rise to the occasion and build something so grand, or would the sheer scale of the endeavor prove too much for us to handle? As we grapple with these questions, one thing is clear. The Dyson Sphere isn't just a feat of engineering, it's a test of humanity's ambition, creativity, and resilience. And while the road to building one is fraught with challenges, it's a journey that could redefine what it means to be a spacefaring civilization. But before we get too carried away, let's take a step back and compare these two incredible visions, terraforming Mars and building a Dyson Sphere, to see which one might be the cooler, more achievable dream. Now, let's tackle one of the most mind-bending questions about the Dyson Sphere. How long would it actually take to build one? If we're talking about a structure designed to encircle the sun and capture its energy, we're not looking at a weekend DIY project. This is a task that could stretch across thousands of years, depending on the technology and resources available. Some estimates suggest that even with advanced robotics and AI, constructing a Dyson Sphere could take anywhere from several centuries to millennia. Why so long? Well, consider the sheer scale of the project. We're talking about building millions, if not billions, of solar collectors, each one requiring precise engineering and placement. Add to that the need to mine and transport materials from across the solar system, and you've got a timeline that makes even the most ambitious Earth-based megaprojects look like child's play. But here's where things get interesting. Some experts argue that advancements in artificial intelligence and automation could dramatically speed up the process. Imagine swarms of self-replicating robots capable of mining asteroids, refining materials, and assembling solar collectors without human intervention. These machines could work around the clock, tirelessly building the Dyson Sphere piece by piece. In this scenario, the timeline might shrink to just a few centuries, still a monumental task, but one that feels slightly more within reach. Of course, even with cutting-edge technology, the timeline raises another critical question. Would humanity stay committed to such a long-term project? History shows that we often struggle to maintain focus on goals that extend beyond a single generation. Think about the construction of the Great Wall of China or the cathedrals of medieval Europe, projects that spanned centuries and required unwavering dedication. A Dyson Sphere would demand that same level of patience and persistence, but on an even grander scale. And then there's the issue of priorities. Would we be willing to invest in a project that might not benefit us directly, but could transform the lives of future generations? Or would we opt for shorter-term solutions to our energy needs, like fusion reactors or advanced solar farms? These are questions that go beyond engineering and touch on the very nature of human ambition and cooperation. The timeline for building a Dyson Sphere isn't just a technical challenge, it's a test of our ability to think beyond our own lifetimes. It forces us to confront the limits of our patience, our resources, and our vision for the future. But it also offers a glimpse of what humanity could achieve if we dared to dream on a cosmic scale. So, while the idea of a Dyson Sphere might seem impossibly distant, it's a reminder that some of our greatest achievements require not just innovation, but also the willingness to invest in a future we may never see. And as we ponder this, it's worth asking, what kind of legacy do we want to leave for the generations to come? A thriving, energy-abundant civilization powered by the sun, or something else entirely? The choice, in many ways, is ours to make. Now, let's weigh the feasibility of these two awe-inspiring projects, terraforming Mars and building a Dyson Sphere. Both are undeniably ambitious, but when it comes to practicality, they sit on opposite ends of the spectrum. Terraforming Mars, while still a colossal challenge, relies on technologies that are already within our grasp, or at least within the realm of possibility. We're talking about atmospheric manipulation, genetic engineering, and planetary science fields that are advancing rapidly, even if they're not yet ready for such a massive undertaking. On the other hand, building a Dyson Sphere is a whole different beast. This megastructure would require breakthroughs in materials science, space construction, and energy transmission that we can barely imagine today. Think about it, we'd need to mine and process materials on an astronomical scale, develop self-replicating robots to assemble the structure in space, and figure out how to transmit energy across vast distances without losing efficiency. These are challenges that push the boundaries of what we currently consider possible. So which one is more feasible? In the near term, terraforming Mars seems like the more achievable goal. It's a project that builds on existing technologies and scientific principles, even if it requires significant advancements. We're already exploring ways to manipulate atmospheres and engineer organisms for extreme environments. And while the scale of terraforming Mars is daunting, it's not entirely out of reach. But here's the twist: feasibility doesn't necessarily make something cooler. Sure, terraforming Mars might be the more realistic option, but the sheer audacity of a Dyson Sphere is hard to ignore. Imagine harnessing the power of an entire star, a feat that would redefine humanity's place in the universe. The Dyson Sphere represents a level of ambition and imagination that goes beyond practicality, tapping into our deepest dreams of what we could achieve if we dared to think big. That said, feasibility does matter when it comes to inspiring action. A project that feels achievable, even if it's incredibly difficult, can galvanize people and resources in a way that a purely theoretical idea might not. Terraforming Mars could serve as a stepping stone, a tangible goal that drives innovation and collaboration, while the Dyson Sphere remains a distant or inspiring vision. Ultimately, the question isn't just about which project is more feasible, it's about what kind of future we want to build. Do we aim for a second home among the stars, reshaping a planet to suit our needs? Or do we dream of harnessing the power of a star, unlocking energy on a scale that could transform civilization? Both visions are incredible in their own right, and both push us to think beyond the limits of what we know. As we consider these possibilities, it's worth asking, which one captures your imagination more? Is it the idea of walking on a green, thriving Mars, or the thought of a civilization powered by the energy of the sun? The answer might just reveal what kind of future you'd like to see, and what kind of challenges you'd be willing to tackle to get there. There's something undeniably captivating about the idea of terraforming Mars. Picture this: a world that's currently a cold, dusty wasteland transformed into a vibrant, Earth-like paradise. Rolling green hills, sparkling blue oceans, and bustling cities under a pinkish sky. It's a vision that feels like it's straight out of a sci-fi epic. The sheer audacity of reshaping an entire planet to suit our needs is both inspiring and humbling. It's a testament to humanity's ingenuity and our relentless drive to push boundaries, to take what seems impossible and make it real. But it's not just about the science or the engineering, it's about the romance of it all. The idea of living on another planet taps into something deep within us, a longing for exploration and adventure. Imagine stepping onto the surface of Mars, not as a visitor in a spacesuit, but as a resident of a thriving colony. Walking through forests that we planted, sailing on oceans we created, and looking up at Earth as a distant, twinkling star in the night sky. It's a dream that speaks to our curiosity, our desire to explore the unknown, and our hope for a future where humanity isn't confined to a single planet. And let's not forget the symbolism. Terraforming Mars isn't just about survival or expansion, it's about transformation. It's about taking a lifeless world and breathing life into it, turning a barren landscape into a home. It's a reminder that even in the harshest environments, life can find a way. This idea resonates on a deeply human level, evoking themes of resilience, creativity, and the power of collective effort. But here's the question: does the cool factor of terraforming Mars hold up when compared to the mind-bending scale of a Dyson Sphere? On one hand, Mars offers a tangible, relatable vision of the future, a second Earth that feels within reach even if it's centuries away. On the other, a Dyson Sphere represents something almost incomprehensible, a structure so vast it could encircle a star, harnessing energy on a scale that defies imagination. So, which one is cooler? It depends on what excites you more, the idea of reshaping a planet and creating a new home among the stars, or the sheer audacity of building a megastructure that could power an entire civilization for millennia. Both ideas are awe-inspiring in their own way, and both push the boundaries of what we think is possible. But perhaps the real cool factor lies in the fact that we're even having this conversation, that humanity is daring to dream on such a cosmic scale. As we weigh these two visions, it's worth asking, which one captures your imagination more? Is it the thought of walking on a green, thriving Mars, or the idea of a civilization powered by the energy of a star? The answer might just reveal what kind of future you'd like to see and what kind of challenges you'd be willing to tackle to get there. Now, let's talk about the cool factor of building a Dyson Sphere, because if there's one thing that screams human ambition, it's the idea of capturing the energy of an entire star. This isn't just about solving Earth's energy crisis or powering our cities. It's about redefining what it means to be a spacefaring civilization. A Dyson Sphere isn't just a megastructure. It's a symbol of humanity's potential to think on a cosmic scale, to reach beyond our limits and claim the power of a star as our own. Think about it, the Sun, a blazing ball of plasma at the heart of our solar system, emits enough energy in a single second to power human civilization for hundreds of thousands of years. A Dyson Sphere would allow us to tap into that unimaginable energy reserve, unlocking possibilities that sound like they belong in a sci-fi novel. Imagine interstellar travel powered by the sun's energy, or massive space habitats thriving on the limitless power of a star. The sheer audacity of the idea is enough to make anyone's jaw drop, but it's not just the scale that makes a Dyson Sphere so cool, it's the implications. Building such a structure would require advancements in technology, engineering, and cooperation that we can barely fathom today. It would push us to develop self-replicating robots, advanced materials, and energy transmission systems that could revolutionize life as we know it. And let's not forget the societal impact. A Dyson Sphere would demand global collaboration on an unprecedented level, uniting humanity behind a shared vision of the future. Then there's the thrill of the unknown. A Dyson Sphere isn't just a practical solution to our energy needs, it's a gateway to the stars. With the sun's power at our fingertips, we could explore distant galaxies, build colonies on far-off worlds, and maybe even encounter other intelligent life. It's a vision that taps into our deepest desires for exploration and discovery, reminding us that the universe is full of possibilities waiting to be unlocked. But perhaps the coolest thing about a Dyson Sphere is what it says about us as a species. It's a testament to our ingenuity, our determination, and our refusal to accept limits. Building something so vast and complex would be the ultimate expression of human creativity, proving that we're capable of achieving the impossible when we set our minds to it. So, while Terraforming Mars offers a tangible, relatable vision of the future, a Dyson Sphere takes things to a whole new level. It's not just about reshaping a planet, it's about reshaping our understanding of what's possible. It's a dream that challenges us to think bigger, to aim higher, and to imagine a future where the stars are within our reach, and that in itself is pretty cool. As we wrap up this exploration of humanity's grandest ambitions, it's worth reflecting on what these ideas mean for us. Whether it's transforming Mars into a second Earth or building a Dyson Sphere to harness the power of the sun, both visions push us to think beyond the here and now. They remind us that the future is full of possibilities and that the only limit is our imagination. So, which one captures your vision of the future? A thriving Mars or a civilization powered by the energy of a star? The choice, in many ways, is yours to make. When we talk about terraforming Mars, it's easy to get swept up in the grandeur of the idea, turning a barren world into a lush, habitable paradise. But what often gets overlooked are the environmental implications, not just for Mars, but for Earth as well. After all, reshaping an entire planet isn't just a technical challenge, it's an ethical one too. Let's start with Mars itself. Right now, the planet is a cold, lifeless desert, but that doesn't mean it's devoid of potential. Scientists have long speculated that Mars might harbor microbial life, either deep underground or in its icy polar regions. If we were to terraform the planet, we could inadvertently destroy these ecosystems before we even discover them. Imagine the irony. In our quest to create life on Mars, we might wipe out the very life forms that could teach us about the origins of life itself. And then there's the question of unintended consequences. Altering Mars' atmosphere and surface could set off a chain reaction of environmental changes. For example, releasing greenhouse gases to warm the planet might sound straightforward, but what if it triggers runaway climate processes we can't control? Mars' thin atmosphere and lack of a magnetic field make it a delicate system, and tampering with it could lead to unforeseen challenges like toxic chemical reactions or unstable weather patterns. But the environmental impact isn't limited to Mars. Terraforming would require an enormous amount of resources: water, energy, and raw materials, most of which would have to come from Earth or nearby celestial bodies. Mining asteroids or transporting materials from Earth could strain our planet's already fragile ecosystems. And let's not forget the carbon footprint of launching thousands of rockets into space. The irony here is hard to ignore. In our effort to create a second home, we might further damage the one we already have. This raises a deeper ethical question. Should we prioritize terraforming Mars over addressing Earth's environmental crises? Climate change, deforestation, and pollution are urgent issues that demand our attention and resources. Diverting those resources to Mars could be seen as neglecting our responsibility to protect and preserve our own planet. On the other hand, some argue that terraforming Mars could serve as a kind of insurance policy, ensuring humanity's survival in case Earth becomes uninhabitable. These dilemmas add a layer of complexity to the idea of terraforming. It's not just about whether we can do it, it's about whether we should. The environmental impact, both on Mars and Earth, forces us to weigh the risks and rewards, to consider not just the technical challenges but the moral ones as well. As we grapple with these questions, it's worth remembering that every decision we make about Mars has ripple effects, both here and there. Terraforming isn't just a scientific endeavor, it's a reflection of our values, our priorities, and our vision for the future. And as we dream of reshaping another world, we must also ask ourselves, what kind of world do we want to leave behind? Now, let's shift our focus to the environmental impact of building a Dyson Sphere. While the idea of harnessing the sun's energy on a cosmic scale sounds like a dream come true, it's not without its own set of challenges, especially when it comes to the environment. But here's the twist: unlike terraforming Mars, where the environmental concerns are planetary, the impact of a Dyson Sphere would be felt across the solar system. To build a Dyson Sphere, we'd need to mine materials on an unprecedented scale. Think about it, we're talking about dismantling entire planets, moons, or asteroids to gather the raw materials needed for construction. This process alone could disrupt the delicate balance of celestial bodies, potentially altering their orbits or even destroying them entirely. For example, mining Mercury for its rich metal deposits might seem like a logical choice, but doing so could destabilize its orbit, affecting the entire inner solar system. And then there's the issue of space debris. Constructing a Dyson Sphere would involve launching millions of solar collectors into orbit around the Sun. Each one of these collectors would need to be precisely positioned and maintained, but even the smallest miscalculation could lead to collisions, creating clouds of debris that could threaten other spacecraft or even Earth itself. Managing this debris would require advanced tracking systems and cleanup technologies, adding another layer of complexity to the project. But here's where things get interesting. While the construction of a Dyson Sphere might have significant environmental costs, the long-term benefits could be transformative. Imagine a world powered by unlimited clean energy, where fossil fuels are a thing of the past and climate change is no longer a threat. A Dyson Sphere could provide the energy needed to power advanced technologies, from carbon capture systems to large-scale desalination plants. helping us address some of Earth's most pressing environmental challenges. Of course, this raises an important question. Do the benefits outweigh the costs? On one hand, the disruption caused by mining and construction could have lasting effects on the solar system. On the other, the potential for clean, limitless energy could revolutionize life on Earth and beyond. It's a classic case of short-term pain for long-term gain, forcing us to weigh the immediate environmental impact against the promise of a sustainable future. And let's not forget the ethical dimension. Just as with terraforming Mars, building a Dyson Sphere forces us to confront questions about our responsibility to the cosmos. Do we have the right to alter celestial bodies for our own benefit? What if our actions inadvertently harm potential extraterrestrial ecosystems? These are questions that don't have easy answers, but they're essential to consider as we dream of a future among the stars. Ultimately, the environmental impact of a Dyson Sphere highlights the trade-offs involved in any grand, futuristic project. It's a reminder that even the most ambitious dreams come with consequences, and that every decision we make, whether on Earth or in space, has ripple effects that extend far beyond our immediate goals. As we ponder these challenges, it's worth asking, what kind of future do we want to create, and what are we willing to sacrifice to get there? So, while the idea of a Dyson Sphere offers a tantalizing vision of limitless energy and cosmic exploration, it also forces us to think critically about the environmental and ethical implications of our actions. It's a conversation that goes beyond science and engineering, touching on the very essence of what it means to be a responsible, forward-thinking species. And as we navigate these complex questions, one thing is clear: the future is full of possibilities, but it's up to us to shape it wisely. Now, let's talk about the elephant in the room: money. Terraforming Mars isn't just a scientific and engineering challenge, it's a financial one too. The sheer scale of the project means we're talking about costs that could easily reach into the trillions of dollars. And that's not a one-time expense. This would be a centuries-long investment, requiring sustained funding, innovation, and commitment. So, who's going to foot the bill? First, consider the technology. Developing the tools and systems needed to warm Mars, thicken its atmosphere, and generate oxygen would require massive research and development budgets. We're talking about breakthroughs in fields like planetary engineering, genetic modification, and energy production, areas that are already expensive to explore. Add to that the cost of building and launching the infrastructure needed to transport materials and equipment to Mars, and the price tag starts to look astronomical in every sense of the word. Then there's the logistics. Transporting materials across the vast expanse of space isn't cheap. Every kilogram of equipment, every drop of fuel, and every piece of machinery sent to Mars would come with a hefty price tag. And let's not forget the human element. Sustaining a workforce on Mars, whether it's scientists, engineers, or construction crews, would require constant resupply missions, adding even more to the cost. But here's the real kicker. This isn't a project that can be completed in a few years or even a few decades. Terraforming Mars would take centuries, meaning the financial burden would stretch across generations. Governments and private companies would need to commit to a long-term vision, pouring resources into a project that might not yield tangible results for hundreds of years. That's a tough sell in a world where economic priorities often shift with political cycles and market trends. So, who would be willing to take on such a monumental financial challenge? Governments might see it as a strategic investment, a way to secure humanity's future and establish dominance in space. Private companies, on the other hand, might view it as an opportunity for profit, leveraging Mars resources or creating new markets for space-based industries. But even with these motivations, the question remains, would the economic benefits outweigh the costs? And let's not forget the opportunity cost. Every dollar spent on terraforming Mars is a dollar that could be invested in solving problems here on Earth, whether it's climate change, poverty, or healthcare. Critics argue that focusing on Mars distracts from more immediate concerns, diverting resources away from pressing issues that affect billions of people today. But here's the flip side. Terraforming Mars could also drive economic growth in ways we can't yet predict. The technologies developed for this project could revolutionize industries on Earth, from energy production to agriculture. And the act of building a second home for humanity could inspire innovation, collaboration, and a renewed sense of purpose, creating economic opportunities that extend far beyond the project itself. So, while the economic costs of terraforming Mars are undeniably staggering, they're also part of a larger conversation about what we value as a species. Are we willing to invest in a future that extends beyond our own lifetimes? Can we balance the need to address immediate challenges with the desire to explore and expand our horizons? These are questions that go beyond dollars and cents, touching on the very essence of human ambition and vision. As we weigh the economic realities of terraforming Mars, it's worth remembering that every great endeavor comes with a price. The question is whether we're willing to pay it and what kind of future we want to build in the process. Now, let's talk about the price tag of building a Dyson Sphere, because if terraforming Mars sounds expensive, this project takes the concept of astronomical costs to a whole new level. We're not just talking about trillions of dollars here, we're talking about a financial commitment that could dwarf the GDP of every nation on Earth combined. The sheer scale of the endeavor means we'd need to rethink not just how we spend money, but how we gather and allocate resources on a cosmic scale. First, consider the raw materials. To build a Dyson Sphere, we'd need to mine and process an unimaginable amount of metal, silicon, and other elements. Where would these materials come from? Likely, we'd have to dismantle entire planets, moons, or asteroids, turning them into the building blocks of this megastructure. The logistics alone are mind-boggling. Think about the energy and machinery required to break down celestial bodies and transport their materials across the solar system. And let's not forget the cost of developing the technology to do all of this efficiently. Then there's the construction itself. Building a Dyson Sphere isn't like assembling a skyscraper or even a space station. We're talking about millions, if not billions, of individual solar collectors, each one requiring precise engineering and placement. The process would demand advanced robotics, AI, and automation, all of which would need to operate flawlessly in the harsh environment of space. The cost of developing, deploying, and maintaining these systems would be staggering, not to mention the constant risk of malfunctions or collisions that could set the project back by years or even decades. But here's where things get interesting. While the upfront costs of a Dyson Sphere are almost incomprehensible, the long-term economic benefits could be transformative. Imagine a world powered by unlimited clean energy, where fossil fuels are obsolete and energy scarcity is a thing of the past. The sun emits enough energy in a single second to power human civilization for hundreds of thousands of years. Capturing even a fraction of that energy could revolutionize industries, fuel interstellar travel, and unlock technologies we can barely imagine today. The economic ripple effects would be enormous. With virtually limitless energy, we could power advanced manufacturing, large-scale terraforming projects, and even megacities in space. The cost of goods and services could plummet as energy becomes abundant and cheap. And let's not forget the potential for new industries and job markets centered around space construction, energy transmission, and interstellar exploration. In many ways, a Dyson Sphere could pay for itself over time, creating a self-sustaining economy that benefits humanity for generations. But here's the catch: the timeline. Building a Dyson Sphere wouldn't happen overnight or even within a single lifetime. It's a project that could take centuries, if not millennia, to complete. That means the economic benefits wouldn't be immediate, and the financial burden would fall on generations who might never see the project finished. This raises a critical question. Are we willing to invest in a future that extends far beyond our own lifetimes? And let's not overlook the opportunity cost. Every dollar spent on a Dyson Sphere is a dollar that could be invested in solving problems here on Earth, whether it's climate change, poverty, or healthcare. Critics argue that focusing on such a distant, abstract project distracts from more immediate concerns, diverting resources away from pressing issues that affect billions of people today. But here's the flip side. The technologies developed for a Dyson Sphere could have profound applications on Earth. Advances in robotics, materials science, and energy transmission could drive innovation across multiple industries, creating economic opportunities that extend far beyond the project itself. In a way, the journey to build a Dyson Sphere could be just as valuable as the destination. So, while the economic costs of a Dyson Sphere are undeniably staggering, they're also part of a larger conversation about what we value as a species. Are we willing to invest in a future that extends beyond our own lifetimes? Can we balance the need to address immediate challenges with the desire to explore and expand our horizons? These are questions that go beyond dollars and cents, touching on the very essence of human ambition and vision. As we weigh the economic realities of building a Dyson Sphere, it's worth remembering that every great endeavor comes with a price. The question is whether we're willing to pay it and what kind of future we want to build in the process. Now, let's dive into one of the most exciting aspects of terraforming Mars, the role of artificial intelligence. While the idea of transforming a barren planet into a thriving world is already mind-blowing, the integration of AI could take this vision to a whole new level. Imagine a future where intelligent machines work alongside humans or even independently to design, build, and manage the complex systems needed to make Mars habitable. It's not just a sci-fi dream, it's a real possibility that could revolutionize how we approach this monumental task. One of the biggest challenges of terraforming Mars is the sheer complexity of the process. From warming the planet to generating oxygen, every step requires precise planning and execution over centuries. This is where AI could shine. Advanced algorithms could analyze vast amounts of data, predicting how changes to the atmosphere or surface might impact the planet's environment. They could optimize resource use, ensuring that every ounce of material is used efficiently, and even identify potential risks before they become major problems. But AI's role wouldn't stop at planning. Imagine self-replicating machines powered by artificial intelligence that could mine Martian soil, extract water from ice, and construct habitats or infrastructure. These machines could work around the clock, tirelessly building the foundations of a new world without the need for constant human oversight. Over time, they could even adapt to changing conditions, improving their efficiency and effectiveness as they go. AI could also play a critical role in monitoring the terraforming process. Sensors and drones equipped with intelligent systems could track atmospheric changes, soil composition, and even the growth of plant life, providing real-time feedback to ensure everything is on track. This constant flow of data would allow us to make adjustments on the fly, fine-tuning the process to achieve the best possible results. And let's not forget the human element. While AI could handle much of the heavy lifting, it would also free up human scientists and engineers to focus on the creative and strategic aspects of the project. Instead of spending years on repetitive tasks, they could tackle the big picture questions, like how to create a sustainable ecosystem or how to ensure the long-term survival of Martian colonies. The integration of AI into terraforming efforts isn't just about making the process faster or more efficient, it's about making it possible. Without intelligent systems to manage the complexity and scale of the project, terraforming Mars might remain a distant dream. But with AI, we could turn that dream into a reality, paving the way for a future where humanity thrives on 2 planets instead of 1. Of course, this raises important questions about the role of AI in our future. How much control should we give to machines? What happens if something goes wrong? These are challenges we'll need to address as we move forward. But one thing is clear: artificial intelligence has the potential to be a game changer in our quest to terraform Mars, and it's an idea that's as exciting as it is transformative. As we look to the future, it's worth asking, what other roles could AI play in shaping our destiny among the stars? The possibilities are as vast as the universe itself, and they remind us that the future of space exploration isn't just about technology. It's about imagination, innovation, and the endless potential of human creativity. Now, let's shift our focus to the role of artificial intelligence in building a Dyson Sphere. Just as AI could revolutionize the process of terraforming Mars, it would be absolutely essential in tackling the monumental task of constructing a megastructure capable of harnessing the energy of an entire star. The sheer scale and complexity of a Dyson Sphere demand not just human ingenuity, but the precision, efficiency, and tireless work ethic of advanced AI systems. Imagine this: designing a Dyson Sphere isn't just about creating a blueprint for a massive structure. It's about solving a puzzle on a cosmic scale. Every solar collector, every energy transmission system, and every piece of infrastructure would need to be meticulously planned and optimized. This is where AI comes in. Advanced algorithms could analyze countless variables, from the gravitational forces at play to the optimal placement of each component, ensuring the structure is both stable and efficient. But the role of AI wouldn't stop at design. Building a Dyson Sphere would require mining and processing materials on an unprecedented scale, and here, intelligent machines could take the lead. Picture swarms of autonomous robots powered by AI, scouring asteroids or even dismantling planets to gather the raw materials needed for construction. These machines could work tirelessly without the need for rest or resupply, drastically speeding up the process and reducing the risks to human workers. Once the materials are gathered, AI would play a critical role in assembling the Dyson Sphere. Think about the logistics. Millions, if not billions, of solar collectors would need to be precisely positioned and connected, all while orbiting the Sun at incredible speeds. AI-driven construction systems could manage this process with unparalleled accuracy, coordinating the movements of countless drones and robots to ensure everything fits together perfectly. And let's not forget maintenance. A Dyson Sphere isn't a static structure, it's a dynamic system that would require constant monitoring and adjustment. AI could oversee this process, detecting and repairing damage, optimizing energy transmission, and even predicting potential issues before they arise. This level of oversight would be crucial in ensuring the long-term stability and functionality of the megastructure. The role of AI in building a Dyson Sphere highlights something profound: the intersection of technology and ambition. It's not just about creating a tool to solve a problem, it's about pushing the boundaries of what we think is possible. AI represents the ultimate partner in this endeavor, a tireless collaborator that can handle the complexity and scale of a project that would otherwise be beyond human capability. But here's the twist: while AI could make building a Dyson Sphere feasible, it also raises important questions about the future of human-machine collaboration. How much control should we give to AI in such a massive project? What happens if something goes wrong? These are challenges we'll need to address as we move forward, but they also remind us that the future of space exploration isn't just about technology, it's about how we choose to use it. As we consider the role of AI in shaping humanity's future, it's worth reflecting on what this means for us as a species. Building a Dyson Sphere isn't just a technical challenge, it's a testament to our ability to dream big and work together, whether with each other or with the machines we create. And in that sense, it's not just a project for the stars, it's a project for the ages. So, while the idea of a Dyson Sphere might seem like science fiction, the role of AI in making it a reality is anything but. It's a reminder that the future of space exploration is as much about innovation and collaboration as it is about ambition and vision. And as we look to the stars, it's worth asking, what other incredible feats could we achieve when humans and machines work together? The possibilities are as limitless as the universe itself. Now, let's tackle one of the most thought-provoking aspects of terraforming Mars, the ethical implications. While the idea of transforming a barren planet into a thriving world is undeniably exciting, it also forces us to confront some profound moral questions. What gives humanity the right to reshape another planet? And what if Mars isn't as lifeless as we think? These aren't just hypothetical musings, they're critical considerations that could shape how we approach the future of space exploration. One of the biggest ethical dilemmas revolves around the possibility of Martian life. Right now, Mars appears to be a cold, desolate world, but scientists haven't ruled out the existence of microbial life, especially beneath the surface or in its icy polar regions. If we were to terraform Mars, we could inadvertently destroy these ecosystems before we even discover them. Imagine the irony. In our quest to create life on Mars, we might wipe out the very life forms that could teach us about the origins of life itself. This raises a fundamental question. Do we have the right to alter another planet's environment, especially if it might already harbor life? Then there's the broader issue of planetary stewardship. Earth has taught us the consequences of unchecked environmental manipulation, deforestation, pollution, and climate change are stark reminders of what happens when we prioritize progress over preservation. Terraforming Mars would involve similar risks but on a planetary scale. Releasing greenhouse gases, redirecting comets, or introducing organisms could set off unintended chain reactions, destabilizing Mars' delicate environment in ways we can't predict. Are we prepared to take responsibility for those consequences, even if they unfold centuries after we've begun the process? Another layer of the ethical debate centers on humanity's role in the universe. Some argue that terraforming Mars is a natural extension of our survival instinct, a way to ensure the long-term survival of our species. Others see it as an act of hubris, a belief that we have the right to reshape the cosmos to suit our needs. This tension between survival and humility lies at the heart of the terraforming debate, forcing us to ask, are we explorers, caretakers, or conquerors? And let's not forget the cultural and philosophical implications. Mars has long captured the human imagination, symbolizing everything from the unknown to the possibility of new beginnings. By terraforming it, we risk losing something intangible, the raw, untouched beauty of a world that has existed for billions of years without human interference. Should we preserve Mars as a kind of cosmic wilderness, a reminder of the universe's vastness and mystery? Or do we embrace the idea that humanity's destiny is to leave its mark on the stars? These ethical questions don't have easy answers, but they're essential to consider as we dream of a future among the stars. Terraforming Mars isn't just a scientific or engineering challenge, it's a moral one, forcing us to confront our values, priorities, and vision for the future. As we weigh the possibilities, it's worth asking, what kind of legacy do we want to leave, not just for ourselves, but for the universe as a whole? So, while the idea of a green, thriving Mars is undeniably appealing, it's also a reminder that every great endeavor comes with responsibilities. The ethical implications of terraforming challenge us to think beyond the technical and consider the deeper questions about who we are and what we stand for. And in doing so, they invite us to imagine a future that's not just about survival, but about wisdom, humility, and respect for the cosmos we call home. Now, let's turn our attention to the ethical implications of building a Dyson Sphere. While the idea of harnessing the energy of an entire star is undeniably awe-inspiring, it also raises some profound moral questions. After all, constructing such a megastructure isn't just a technical challenge. It's a decision that could reshape the solar system and force us to confront our priorities as a species. One of the most pressing ethical concerns revolves around resource use. To build a Dyson Sphere, we'd need to mine and process materials on an unprecedented scale, potentially dismantling entire planets, moons, or asteroids. This raises a critical question. Do we have the right to alter or destroy celestial bodies for our own benefit? These objects aren't just lifeless rocks, they're part of the cosmic ecosystem, each with its own history and potential scientific value. By repurposing them for construction, we risk losing valuable insights into the origins of our solar system and the universe itself. Then there's the issue of prioritization. Building a Dyson Sphere would require an enormous investment of time, energy, and resources that could instead be used to address pressing challenges here on Earth. Climate change, poverty, and inequality are urgent issues that demand immediate attention. Some argue that diverting resources to a cosmic megastructure would be irresponsible, especially when billions of people are struggling to meet their basic needs. Should we focus on solving Earth's problems before venturing into the stars, or is it possible to pursue both goals simultaneously? But here's another angle. A Dyson Sphere could also be seen as a solution to Earth's challenges, not a distraction from them. By harnessing the sun's virtually limitless energy, we could power advanced technologies to combat climate change, provide clean water, and improve living standards worldwide. The energy abundance created by a Dyson Sphere could revolutionize life on Earth, offering a sustainable future for generations to come. In this light, the project isn't just about cosmic ambition, it's about securing humanity's survival and prosperity. Of course, this raises the question of balance. How do we weigh the potential benefits of a Dyson Sphere against the ethical and environmental costs? It's a dilemma that forces us to think critically about our values and priorities. Are we willing to sacrifice parts of the solar system for the sake of progress? Or should we strive to preserve the cosmos as a kind of universal heritage? And let's not forget the philosophical dimension. Building a Dyson Sphere isn't just a technical feat, it's a statement about humanity's place in the universe. It reflects our desire to explore, to innovate, and to claim the stars as our own. But it also challenges us to consider the responsibilities that come with such power. Do we have the wisdom to use this technology wisely, or are we risking the same mistakes we've made on Earth but on a cosmic scale? These ethical questions don't have easy answers, but they're essential to consider as we dream of a future among the stars. Building a Dyson Sphere isn't just about engineering, it's about morality, responsibility, and the kind of legacy we want to leave behind. As we weigh the possibilities, it's worth asking, what kind of future do we want to create, and what are we willing to sacrifice to get there? So, while the idea of a Dyson Sphere offers a tantalizing vision of limitless energy and cosmic exploration, it also forces us to think critically about the ethical implications of our actions. It's a reminder that every great endeavor comes with consequences, and that the choices we make today will shape the universe for generations to come. As we navigate these complex questions, one thing is clear: the future is full of possibilities, but it's up to us to shape it wisely. Now, let's step away from the science and engineering for a moment and consider something equally profound: the cultural impact of terraforming Mars. Beyond the technical challenges and ethical debates, the idea of transforming a barren world into a thriving Earth-like planet has the power to ignite the human imagination in ways that transcend borders, languages, and generations. It's not just a scientific endeavor, it's a cultural phenomenon, one that could reshape how we see ourselves and our place in the universe. Think about it. Throughout history, humanity's greatest achievements have always been accompanied by a surge of creativity. The Apollo moon landings inspired countless works of art, music, and literature, capturing the awe and wonder of exploring the unknown. Terraforming Mars could have a similar effect, but on an even grander scale. The very idea of creating a second Earth, a world where humanity could flourish anew, would resonate deeply with people around the globe, sparking a renaissance of creativity and innovation. Artists, writers, and filmmakers would undoubtedly be drawn to the story of Mars transformation. Imagine novels exploring the lives of the first settlers, struggling to build a new society on a hostile world. Picture films depicting the dramatic moments of the terraforming process, from the first breathable air to the first rain on Martian soil. Even visual artists could find inspiration in the stark beauty of Mars landscapes, capturing the tension between its barren past and its vibrant future. But the cultural impact wouldn't stop at art. Terraforming Mars could also inspire new philosophies and ways of thinking. The project would force us to confront fundamental questions about our relationship with nature, technology, and each other. What does it mean to reshape a planet? What responsibilities come with such power? These questions could spark global conversations, challenging us to rethink our values and priorities as a species. And then there's the unifying potential. Terraforming Mars isn't just a project for scientists or engineers. It's a vision that could bring people together. The idea of creating a second home for humanity could foster a sense of shared purpose, transcending political, cultural, and economic divides. It's a reminder that, despite our differences, we're all part of the same story, a story that's still being written. The cultural significance of terraforming Mars goes beyond the practical. It's a symbol of human potential, a testament to our ability to dream big and work together to achieve the impossible. It's a reminder that the future isn't something that happens to us, it's something we create together. So, while the technical challenges of terraforming Mars are immense, its cultural impact could be even greater. It's a project that has the power to inspire, to unite, and to redefine what it means to be human. And in that sense, it's not just about reshaping a planet, it's about reshaping ourselves. As we look to the stars, it's worth asking, what kind of stories do we want to tell about our future? What kind of legacy do we want to leave for the generations to come? The answers to these questions might just shape the course of history, not just on Mars, but here on Earth as well. Now, let's shift our focus to the cultural impact of building a Dyson Sphere. While the technical and ethical aspects of this megastructure are fascinating, its influence on human culture could be just as profound. Imagine a future where humanity has harnessed the energy of an entire star, a feat so monumental that it reshapes not just our technology, but our very identity as a species. The Dyson Sphere isn't just an engineering marvel, it's a symbol of what we're capable of when we dare to dream on a cosmic scale. The sheer audacity of the idea would inspire awe and wonder across the globe. Think about it, for centuries the sun has been a source of life, mythology, and inspiration. Cultures around the world have worshipped it, studied it, and marveled at its power. To build a structure that captures that power would be a transformative moment in human history, one that could unite us in a shared sense of achievement. It's the kind of project that could redefine our understanding of what it means to be human, reminding us that our potential is as vast as the universe itself. Art and storytelling would undoubtedly be transformed by the concept of a Dyson Sphere. Imagine the novels, films, and artworks that could emerge from this vision. Writers might explore the lives of the engineers and dreamers who made it possible, or imagine the societal shifts that come with limitless energy. Filmmakers could depict the construction process, capturing the drama and danger of building something so immense. Even visual artists might find inspiration in the interplay of light and shadow on the sphere's surface, creating works that reflect both its grandeur and its mystery. But the cultural impact wouldn't stop at art. A Dyson Sphere could also inspire new philosophies and ways of thinking. The project would force us to confront fundamental questions about our relationship with technology, nature, and the cosmos. What does it mean to harness the power of a star? What responsibilities come with such immense capability? These questions could spark global conversations, challenging us to rethink our values and priorities as a species. And then there's the unifying potential. Building a Dyson Sphere isn't just a project for scientists or engineers, it's a vision that could bring people together. The idea of harnessing the sun's energy could foster a sense of shared purpose, transcending political, cultural, and economic divides. It's a reminder that, despite our differences, we're all part of the same story, a story that's still being written. The cultural significance of a Dyson Sphere goes beyond the practical. It's a symbol of human potential, a testament to our ability to dream big and work together to achieve the impossible. It's a reminder that the future isn't something that happens to us, it's something we create together. So, while the technical challenges of building a Dyson Sphere are immense, its cultural impact could be even greater. It's a project that has the power to inspire, to unite, and to redefine what it means to be human. And in that sense, it's not just about harnessing a star, it's about harnessing our collective imagination and ambition. As we look to the stars, it's worth asking, what kind of stories do we want to tell about our future? What kind of legacy do we want to leave for the generations to come? The answers to these questions might just shape the course of history, not just for us, but for the universe as a whole. So, what does the future hold for terraforming Mars? As we look ahead, it's clear that this ambitious vision is no longer confined to the realm of science fiction. Advances in technology are bringing us closer to making this dream a reality, but the road ahead is still filled with challenges and uncertainties. Let's explore what the next few centuries might look like for humanity's quest to transform the Red Planet. One of the most exciting developments is the role of artificial intelligence. AI could revolutionize every stage of the terraforming process, from designing the systems needed to warm the planet to managing the complex ecosystems that would sustain life. Imagine intelligent machines analyzing Martian soil, optimizing resource use, and even predicting environmental changes before they happen. These systems could work tirelessly, accelerating the pace of progress and reducing the risks of human error. Genetic engineering is another game changer. Scientists are already experimenting with organisms that can survive extreme conditions, from bacteria that thrive in acidic environments to plants that grow in low gravity. By engineering these life forms to thrive on Mars, we could kickstart the process of creating a breathable atmosphere and fertile soil. Over time, these organisms could transform the planet's surface, paving the way for more complex ecosystems and, eventually, human habitation. But technology alone won't be enough. The future of terraforming Mars also depends on our ability to address the ethical and environmental challenges that come with reshaping another world. Should we prioritize Mars over solving Earth's problems? What if we discover life on Mars? Do we have the right to alter its environment? These questions will shape the decisions we make in the coming decades, forcing us to balance ambition with responsibility. Funding is another major hurdle. Terraforming Mars would require trillions of dollars and centuries of sustained investment. governments, private companies, and international organizations would need to work together, committing to a long-term vision that might not yield results for generations. This raises a critical question. Are we willing to invest in a future that extends beyond our own lifetimes? Despite these challenges, the future of terraforming Mars is a topic of endless fascination and debate. It's a vision that captures our imagination, inspiring us to dream big and push the boundaries of what's possible. Whether or not we succeed, the journey itself could drive innovation, collaboration, and a renewed sense of purpose, shaping the course of human history in ways we can't yet predict. As we look to the stars, it's worth asking, what kind of future do we want to create? A thriving Mars could be a testament to human ingenuity and resilience, a reminder that even the most daunting challenges can be overcome with creativity and determination. But it's also a reminder that every great endeavor comes with responsibilities to each other, to the planet we call home, and to the universe we hope to explore. The future of terraforming Mars is still unwritten, but one thing is certain. It's a story that will continue to captivate us for generations to come. And as we dream of a green, thriving Mars, we're also dreaming of a future where humanity reaches new heights, both on Earth and among the stars. Now, let's turn our gaze to the future of building a Dyson Sphere. While the idea of harnessing the energy of an entire star might seem like the stuff of science fiction, it's a concept that continues to captivate scientists, engineers, and dreamers alike. The road to constructing such a megastructure is undeniably long and fraught with challenges, but recent advancements in space exploration and energy technology suggest that this distant dream might not be as far off as it once seemed. One of the most exciting developments is the rapid progress in space infrastructure. Companies and governments are already investing heavily in technologies like reusable rockets, asteroid mining, and advanced robotics, all of which could play a critical role in building a Dyson Sphere. Imagine fleets of autonomous robots powered by artificial intelligence, mining asteroids for raw materials and assembling solar collectors in orbit around the Sun. These technologies are no longer just theoretical, they're being developed right now, bringing us one step closer to making this cosmic vision a reality. Energy technology is another key piece of the puzzle. The ability to capture, store, and transmit vast amounts of energy is essential for a Dyson Sphere, and breakthroughs in fields like fusion power, wireless energy transmission, and advanced batteries could make this possible. For example, scientists are already experimenting with microwave and laser-based systems to beam energy across long distances, a technology that could be scaled up to transmit solar energy from a Dyson Sphere back to Earth or other colonies. But here's the twist: even with these advancements, the timeline for building a Dyson Sphere remains uncertain. Some experts estimate it could take centuries, if not millennia, to complete such a project. The sheer scale of the endeavor, mining materials, constructing millions of solar collectors, and maintaining the structure in the harsh environment of space presents challenges that are as much about patience and persistence as they are about technology. Yet the idea of a Dyson Sphere continues to inspire. It's a symbol of humanity's boundless ambition, a reminder that we're capable of dreaming on a cosmic scale. The project pushes us to think beyond the limits of our current knowledge, to imagine a future where we're no longer bound by the constraints of our planet. It's a vision that challenges us to innovate, to collaborate, and to strive for something greater than ourselves. And let's not forget the cultural impact. The concept of a Dyson Sphere has already captured the imagination of writers, artists, and filmmakers, inspiring countless works of science fiction. But as the technology to build one becomes more feasible, this vision could shift from fiction to reality, sparking a new wave of creativity and exploration. It's a reminder that the future isn't just something we predict, it's something we create, So, while the future of building a Dyson Sphere is still uncertain, one thing is clear: the idea continues to push the boundaries of what we believe is possible. It's a dream that challenges us to think bigger, to aim higher, and to imagine a future where the stars are within our reach. And in that sense, it's not just a project for the distant future. It's a vision that's shaping the way we think about our place in the universe today. As we look ahead, it's worth asking, what kind of future do we want to build? A Dyson Sphere represents the ultimate expression of human ingenuity and ambition, but it also forces us to confront the challenges and responsibilities that come with such power. The journey to build one might be long and difficult, but it's a journey that could redefine what it means to be a spacefaring civilization. And in the end, isn't that what makes it so exciting? As we wrap up this journey through two of humanity's most awe-inspiring dreams, terraforming Mars and building a Dyson Sphere, it's clear that both ideas are more than just science fiction. They're visions of what we could achieve if we dared to think beyond the limits of our planet. Terraforming Mars offers the promise of a second home, a world we could reshape into a thriving, Earth-like paradise. It's a project that speaks to our desire for exploration, survival, and the sheer thrill of making the impossible possible. On the other hand, a Dyson Sphere represents the ultimate expression of human ingenuity, a megastructure so vast it could harness the energy of an entire star. It's a concept that challenges us to think on a cosmic scale, redefining what it means to be a spacefaring civilization. Both ideas come with their own set of challenges. Terraforming Mars would require centuries of effort, from warming the planet to creating a breathable atmosphere, all while navigating ethical questions about our right to reshape another world. Building a Dyson Sphere, meanwhile, would demand breakthroughs in technology and resource management on a scale we can barely imagine, not to mention the long-term commitment needed to see it through. Yet, despite these hurdles, both projects inspire us to dream bigger, to push the boundaries of what we think is possible, and to imagine a future where humanity's reach extends far beyond Earth. So, which one is cooler? That's a question only you can answer. Are you drawn to the idea of walking on a green, thriving Mars, with Earth shining like a distant star in the sky? Or does the thought of harnessing the power of the sun, unlocking energy on a scale that could transform civilization, ignite your imagination? Both visions are incredible in their own way, and both remind us of the boundless potential of human creativity and ambition. As we look to the stars, it's worth reflecting on what these ideas mean for us as a species. They're not just about survival or progress, they're about who we are and who we want to become. Whether it's transforming a barren planet or building a megastructure that encircles a star, these projects challenge us to think beyond the here and now, to consider the legacy we want to leave for future generations. So, what do you think? Which vision captures your imagination more? A thriving Mars or a civilization powered by the energy of a star? Let us know in the comments below, and don't forget to subscribe for more deep dives into the future of technology, exploration, and the incredible possibilities that lie ahead. The universe is full of wonders, and the best part is, we're just getting started.